Hey guys, once again I'm sorry that I am not in class today, but I wanted to make sure that those of you that completed this on paper had the correct answers. Alright, so the chance that a baseball player will get to hit is estimated to be 23%. How would you describe this likelihood? So remember on that scale, so this is likely as not. This is this is likely, and then this is certain. So 23% would fall there, so it would definitely be unlikely. All right, so a news report states that a hurricane will reach land on Monday or Tuesday, but Tuesday is more likely. Give a number or number range to describe the probability that the hurricane will reach land on Tuesday. So that would be greater than half, but less than 1. All right, number 7. Andrea drew 3 animals, an eagle, a snake, and a shark. She drew each animal twice, once with green eyes and once with red eyes. 10 students chose their favorite drawing. 3 of them chose the shark with red eyes. How many possible outcomes are there in the sample space of her experiment? So there's the first question. How many possible, and then based on the results, what is the experimental probability that a shark with red eyes is not picked? So remember, that's the complement. We need to write it as a percent. So we have 6 outcomes, and so that would be 3/10. So 3 of them chose the shark with red eyes. So 3/10, and then we know that that would be 30%. So the chance of not picking would be 70%. And this is where I got the 10 students right there. All right, number 8. Sophia randomly selects a marble from a bag of marbles and then replaces it. The result of 300 trials are shown. Based on this data set, what is the experimental probability of the selection of a red marble from this bag? State what strategy and tool you use to answer. All right, so we want red marble. So we're going to do 57. Add these all up, and that gives me 300. So if I divide 57 by 300, I get 0.19 or 19%. So strategy-wise, we divided to find the percent. So that's what strategy we use. All right, number 9. In each cycle of a stoplight, the light is green for 30 seconds, yellow for 5, and red for 85 seconds. Leland conducts 500 trials of a simulation to estimate the likelihood that the stoplight will be a particular color when a car reaches it. Use the results to find the experimental of each event. All right, so getting a green light would be 115 over 500, because that's what we have. Of course, that simplifies to 23 over 100, which would be 23%. Okay, yellow light would be 15 over 500. That reduces to 3 over 100, which is, of course, 3%. And then not getting a red, so that would be these two added together, so that would be 130 out of 500, which simplifies to 26 over 100, which is 26%. All right, a bag holds 6 plain bagels, 3 raisin, 2 cheddar, 1 onion. Grace chooses 4 bagels at random without replacing them. What are all possible compound events? So there are exactly 2 plain bagels. There are more onion bagels selected than raisins, and the number of cheddar bagels is equal to the number of plain bagels. So what I did is I did 6 over 12 which is 50% for plain. I did 3/12, which is 25% of raisin. And then I did 2/12, which of course is 1/6, which is 17% of onion. I believe that was, no, was it onion? So this is raisin. This is plain. That had to be cheddar. And then 1/12, which is 8%, which was the onion. Okay? All right, so the experimental probability that Teresa will make a free throw shot in a basketball game is 50. Describe a simulation that can be used to estimate the probability that Teresa will make both of her next 2 free throws. So you could toss 2 coins. So if you get heads on both coins, that would represent making a shot. Anything else represents her at least missing 1 shot. All right, number 12. The table shows the blood types of at least 300 people to donate blood at a blood bank. Use this information to answer the question. What is the experimental probability that the next person to donate blood will have O blood? So 144 over, if I add them all up, I get 300. We can either reduce or I can divide. So I did 144 divided by 300. So that gives me 0.48 or 48 hundredths, which is 48%. All right, if 50 people donate blood on Friday, how can we expect to have type O blood? So we would take that 0.48, multiply by 50, so 24 people would have that blood. All right, then the last one. The experimental probability of winning a prize when playing a carnival game is estimated to be 4%. Based on this information, approximately how many times would a player need to play a game to win 10 prizes? Well, 4 over 100 equals 10 over X. So this time we know the prizes, but we don't know total games. So I can say 4 goes into 10, 2.5. So I'd have to multiply 100 times 2.5, and I would get 250, which is C. All right, so that's it, guys. Make sure that you upload your completed review if you did it on paper into Focus, and if not, make sure the rest of it is into Math. Have a great one.